Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buetow, Editor-in-Chief of PCD&F and Circuits Assembly. In my 3 decades in electronics engineering, perhaps the only thing that never changes is the need for more skilled workers. No matter the state of the economy or the geography, having knowledgeable and competent engineers and operators is always critical, and there are never enough of either. But while the tension is notable between industry and academia over who is responsible for preparing the next generation of workers for specific tasks, some schools are quietly taking the lead by putting in place programs that include true hands-on training in printed circuit board manufacturing. I'm talking specifically about Lorain County Community College. Lorain is in Northeast Ohio, about 30 miles west of Cleveland. In 2018, LCCC became the first community college to offer an applied bachelor's in microelectronic manufacturing. And a year ago, it formed the Manufacturing Electronics and Rework Institute for Training, or MERIT, which is a hands-on training lab. Last spring, the program graduated its first students. And with us today is Johnny Vanderford, the director of MERIT and an assistant professor of MEMS at LCCC. Joining Johnny is Courtney Tenhover, program developer, engineering, business, and information technologies. Johnny and Courtney, welcome to PCB Chat.
Hey, thanks, Mike.
Thank you.
Thanks for great to be on the show.
There's so much I want to ask about the LCCC and the merit programs, Johnny. Let me start by asking, whose idea was this in the first place?
Well, it was the industry's idea in the end. About 8 companies in the year 2012 got together and said, we're short on workforce, and this college isn't graduating people, or no college is graduating people that can work for us starting from the very beginning. They all require potentially a year worth of training, a year worth of on-the-job equipment handling and everything like that. And 9 times out of 10, they're either not skilled to work or they're just not a good enough worker to be able to keep with the team. And they said, when is a college going to actually step up and help us with our workforce shortages? Several of these supporting companies were being hit by, Mike, they're being hit by what's called the silver tsunami, which means their workforce is growing gray hairs and they're getting ready to retire to places where drinks are served with little straw umbrellas in them. And they're taking all of the knowledges that they had with that company and they're leaving that company, and there's nobody fresh coming in. Nobody's graduating from college with the hands-on skills. Nobody knows how to solder coming out of universities or anything like that, or knows very little. They're like one of those, like, yeah, I've seen it on YouTube. I've done it once. And it just wasn't good enough for some of these companies. They were short on workforce. So 8 years ago, they said, hey, is there some, well, 9 years ago, 2012, they said, hey, can somebody help with this? That's when I heard about this, and I said, yeah, I want to join the team here at Lorain County Community College to teach this associate's degree at the time called microelectromechanical systems, or MEMS, and it just kind of took off from there. It's all about helping companies find skilled workforce while also having a training and education system that's meant to train people in an affordable college degree to work for these companies.
Yeah, I would totally agree that folks coming out of engineering school today, they may know very well how gas moves in a chamber, for example. But then if you put them in front of a convection reflow oven, they have no idea how to make that, how to profile, how to make it run, et cetera. So great. Okay. So then what goes into launching a program like this? Did you have to do much market research to convince LCCC of the need?
Well, when we first launched this, where we first looked at, ironically, were the job markets that were asking for people. We went to Indeed. We went to LinkedIn. We went to SMTA, the Surface Mount Technology Association's website, and we said, what do companies want as of right now? What do they want for their technicians? What do they want for their operators? And we were literally just hit with a wave of job requests that just weren't being met. And it seemed like a pretty easy step to say, hey, let's ask the state for a little bit of funding to buy some capital. Let's get buy-in from our college to be able to say, let's launch a class with this, and let's get a professor to teach some classes with this. So they hired me initially as an adjunct instructor while I was working for a packaging company called Smart Microsystems. They make the chips that go onto the boards, and initially they all said, hey, you could do this kind of as a part-time work. We started with 3 students in 2013 and started training them up in what is ESD, what does it mean to ground yourself? Why is it important? We started them with soldering training on doing both through-hole and surface mount components. We started showing them pieces of equipment like, this is how you use a microscope. This is something in some of the cases, like some people sit down on a microscope and it's a legitimately difficult tool for them to use. But if you're going to be working with 0402 and 0201 components with lead-free solder, you better know what you're looking at and how to use the tools that you've got available to you. And so that first year, we had 3 students and 8 supporting companies that were asking for people. And Mike, all 3 of those students got hired in before they got their associate's degree with us. And then the next year, 5 students, all 5 of them hired in. And this all before they got their degree. Some of these students, they got hired in, they said, Dad, this isn't for me. I want to go to another college degree. And that's good. You're helping yourself out. You're helping companies by not working in something you don't like to do. But then we get another student who's like, yeah, I'm an artist. I'm really good at painting. And this one of the students in particular is really good at doing calligraphy on rice. It's a hobby I thought that it was dead a long time ago. She writes on rice. Wouldn't you know it? She's really good at soldering. So what is she doing right now? She's soldering ribbons and zip connectors for the biomedical industry, for cardiovascular systems. So yeah, that's what it started out. It started with employers that told us that this is what our needs are, a small handful of students and some funding from the state to get us some laboratory equipment and training equipment so that we could train and educate these students up to get careers in the industry.
I'm taking a brief break to mention today's sponsor. This podcast is sponsored by Printed Circuit University. Printed Circuit University offers flexible, affordable electronics education on demand. Visit printedcircuituniversity.com to see more than 100 hours of online classes from some of the top professionals in their fields. Let's talk a little bit more about that program curriculum, and then we can get into the facilities and the equipment. What are the prerequisites for matriculating students?
If you could balance a checkbook, that's pretty much all the requirements you really need to get it. Now, I'm serious. You need like a sophomore English and a sophomore, like a high school, sophomore level English, high school math equivalent, and then you're in. This isn't rocket science that we're teaching people how to do. This is how, you know what it is? It's not rocket science. It's not advanced calculus or anything like that. It's hands-on skills that involve you using a tweezers in one hand, a soldering iron in another hand, while looking through a microscope. It involves practice of near surgical skills with a knowledge of material handling as well as working in a quality manufacturing system. That's what it ultimately kind of involves in. The whole program curriculum, in order to get in and start taking classes, you could start, as long as you could pass the high school math and high school English, you can get into this program with it on here. And we've got people in this program that are like it. We've got students who are in the degree as of right now who are coming from art backgrounds, who are coming from nursing backgrounds, who are coming from business, construction, welding, administration. Like, we've got it all the way across the board. We've got folks who are working in one industry and they're going through Jobs Ohio to get some funding, to get some education, to get them into a new career field, right? We've got a retired letter carrier from the U.S. Postal Services. We've got a retired corrections facility officer from the Lorain County Prison. We've got from all over the place. We have a radio broadcaster. One of our students is a radio broadcaster. And what does he know how to do? He knows how to solder circuit boards and manufacture them in high volumes, right? And so the whole curriculum was made by our industry supporters. And so everything that's in our current curriculum is meant to get folks trained up in what is essentially what I would call a blue collar degree, right? There's no calculus, there's no quantum physics, there's no crazy science stuff with it like there. No, it's all skills. Week 1, day 1, this is ESD. This is how you ground. Week 1, day 2, this is a soldering iron. Let's solder some 1206 resistors, all right? And that's where we started out with it on here. The whole associate's degree was entirely built based on our employer needs so that we could train up these folks that may come from all over the place. We're a community college. These are non-standard students who are coming in. They're not just out of high school, although we do get a good amount of them out of high school. They're military veterans using the GI Bill. They're folks who are like, newly divorced parents who are trying to work for the first time because they just haven't had a job for a while, right? They're folks that are coming from all different areas of backgrounds, and with a little bit of some practice and some hands-on training, they're able to work for these companies. They're able to work and expand to these companies because years after years of doing this now we've got over 80 industry supporters within this program. And still to this day, everyone who has ever been through the associate's degree and graduated from the associate's degree has been hired in to work at our 80 industry supporters. That's 100% graduation rate that we've got with it right now. And there aren't a lot of universities and colleges that can say that they've got that in terms of what they've done throughout their history. I'm proud to be able to say that. I'm proud to say that every student that's graduated from here with the associate's degree and our bachelor's degree, Mike, they've all been hired in.
So that's an admirable track record. Now, just so for clarification, the MEMS degree, the applied bachelor's degree, that's a 2-year program that's on top of an associate's degree?
Yeah, so the associate's degree trains very heavily in areas of what I would call hand solder training. We IPC J Standard 001 certify all of our students, in addition to them taking 3 other classes to where they're doing soldering with a soldering iron, with a hot air rework station, using a microscope, doing both through-hole surface mount, lead and lead-free, teaching them the difference between the two. I'll tell you, Mike, every student, we start them off with lead. And because that's just like, you get students who have just never done this before. And so it's like, let's start off with the easy stuff with it, Then we show them lead-free. And they're like, man, this is kind of hard. And it's like, yeah, and you got to learn this if you want to work for some of these companies, because you might be working for a company that only does RoHS lead-free based soldering with it. And so you got to learn how to do this, right? The bachelor's degree feeds off of the associate's degree and basically trains them in high volume PCB production. So by the time that they finish their associate's degree, they've got a whole truckload of hand solder training. They've got a little bit of some PCB design as well as some PCB prototyping experience. And then third thing, most important out of all of that, all I've described as education is at this point, right? Most important out of all of this, we require every student in our associate's degree to be employed for at least 300 hours in order for the student to get their degree and in order for the community college to continue receiving funding from the state via state share of instruction to continue our program. All state colleges get funding based on graduates of their programs. All public schools is what it is. And so every time a student graduates from our program, the state gives us funding. Now, they give funding like that to all the other bigger universities too, but they've got tuitions that are just, astronomically higher than where we are. Our tuition is $3,900 a year for a full-time student. It's the lowest tuition for any associate's degree or bachelor's degree in the entire state of Ohio, all right? So we're dependent on this state share of instruction, this funding coming in from the state. And the logic is, Mike, if a student hasn't been hired by the time they get their associate's degree, not only are they not going to get their degree, the college won't get funding to continue the program. And maybe the college, if they do this enough, should start to look at offering college degrees that do get career experience and do get people hired in. In fact, our bachelor's degree very uniquely requires every student that goes into the bachelor's degree to have work experience in order to get entrance into the bachelor's degree. That's been a very unique criteria for us. But again, 8 years of doing this and putting accountability on us, the college, we've had 100% of folks hired in out of our graduates. And we've got companies that are hungry and interested for more students out of our program as well. But the bachelor's degree has classes in addition to that in high volume PCB manufacturing, how to operate a stencil printer, a pick and place system, a reflow system, an AOI system, not just how to operate, how to program it too, how to design in Altium, and very specifically to design for manufacturing, put in fiducials, put in mounting holes, make sure you've got test points on your circuit board, put on rails so that they can actually fit onto a conveyor without a problem with it. And then we go into additional side tracks in all of these courses with side tracks in like other courses in electronics and testing. So we've got a lot of like how to use a multimeter, how to use the power supply. We've got classes in mechanical design, how to do AutoCAD, SolidWorks, GD&T, and blueprint reading, and then classes in quality, which include ISO 9001, Yellow Belt Six Sigma, lean manufacturing principles, statistical process control, and gauge R&R, right? And I didn't put all this in. The companies wanted it put in. So we put in all of this information so that these companies could get training into their potential workforce. And that way they get a whole pile of potential workforce that if they're interested in working, they let Courtney know. The companies let Courtney know about job descriptions. And then Courtney's actually the funnel between both students getting resumes out to the company, students and alumni, as well as companies that have job requests. They go straight over to Courtney.
So quite literally, you don't get paid until the students get paid.
Yeah, we don't get paid until the student's hired in. So, which makes us uniquely like training and education and somewhat recruiting as well, which I tell you, 8 years have been doing this. It's been fun.
Now, Courtney, you're the program developer, and within the MEMS program is something you call Earn and Learn. What does that mean?
Yep. So the Earn and Learn was the program we developed so students can essentially earn while they learn. But so we worked with employers to begin this program. And what it is students can work with an employer 3 days a week and have their classes scheduled on 2 days a week. So working back with LCC and Johnny, designing it so all their classes can fall on those 2 days, and then leaving them available for the employer for those 3 days a week. So they're not just offering 4 hours here and there. It's more of a consistent schedule for both the student and the employer. And then the goal is it helps employers minimize the time they have to recruit someone. And then hopefully the student has a full-time job at the end of completion. So all the time employers spent in working with the student and training them, it was money well spent because now they have a full-time worker with the skills that they've requested to Johnny.
So let me get this straight. So somebody as a student, they could start as a student and start working at a company outside of LCCC, or hypothetically, they could actually be already employed and start taking classes at LCCC in the MEMS degree program.
Yes, that's correct. Yeah, we've worked both ways where it's students that we're helping find employment or incumbent workers who just want to kind of upskill their skills within this area.
And as Johnny mentioned, you offer courses in assembly plus the opportunity to learn fabrication and design. Do students do all this in Merit, which is that live SMT facility? I mean, walk me through how that would work, or is there actually any classroom-based instruction?
Here, let me take that one, Courtney. So yeah, there are some lecture-based classes. We do lecture and discussion, but Mike, the motto is the only way to learn how to ride a bike is to get on the damn bike and ride it. You know, that's the only way. You're going to watch a YouTube video of someone riding a bike. That doesn't mean you know how to do it. You got to, you want to watch a YouTube video of someone soldering 0402 components or operating a pick and place system. That's grand. Let's sit you down on the equipment to do it. We've got, as of right now, 3 training laboratories in the core classes of our program. One of them is a solder laboratory that's got soldering irons, hot air rework stations, microscopes, ESD testing equipment, electronic testing equipment, and that's where we train folks in the earliest stages of the program. Typically speaking, Mike, before they're employed with one of our employers, a student usually has to work with us for maybe 6 months to a year worth of training and education with us. However, the demand is so high for people as of right now that we've had some students hired in literally within 7-8 weeks of our program. The companies are just like, wait, they've held a soldering iron before? And we say, yeah, we're doing 0603 resistors and polarity specific devices as of right now. It's lead-free solder. Like, oh, please, yes, that's exactly what we need. Everyone else we've ever hired in can't spell solder, let alone do it. So all of a sudden, that's one of our labs. Our second laboratory is very similar, except it's actually in a class 10,000 clean room. Several of our companies make biomedical devices, and they have a need for having people who know how to do electronic manufacturing within a clean room environment. Some of those companies also do things beyond your typical PCB soldering. We've got several companies that do PCB fabrication. So we train students in how to do photolithographic processing, how to do ferric chloride chemical etching, how to do development and chemical handling, and expose them to some of the material processes that it takes to actually fabricate a board. We've also got equipment in our clean room for doing wire bonding and die attach for doing chip scale packaging. And in the case of our class, we do a lot of processing with chip-on board processing. So we die attach, die down, and wire bond them down to a board to create a functional circuit board, with all of it based around functionality. But then on top of that, we've got soldering irons, we've got microscopes, and on top of that, introductory, what I would call semi-automatic introductory equipment for doing SMT prototyping and low volume production. We've got some stencil printers that are more or less more mechanical than they are automated in any way. But it's one of those, like, you're talking about someone in an associate's degree that is seeing this for the first time. We're printing on 5-inch by 5-inch stencils. Yeah, it's not big, but we're a community college. We're using our funding appropriately to be able to give people training, education, and skills for getting hired in. We've got 4 semi-automatic pick and place systems where the operator still has to operate it with their hand on a gantry system, but they've got to load feeders. The feeders have a button where if you push the pickup tool nozzle down onto the button, it feeds fresh parts forward. There's a vacuum nozzle that the operator's got to control with a button in their other hand. We've got a 3-zone reflow oven that's sitting on a bench that teaches them here. This is a belt-driven oven. This is just what you see in the industry is like 10 times this size with it, right? That's all the stuff for our associate's degree. Now, in our bachelor's degree, where we also do a lot of our training at Merit, that's where we've got a high volume stencil printer. We've got the Panasonic stencil printer and Panasonic pick and place system that's fully automated with, I think it's like 48 feeders, both front and rear, and a 20 tray loading system. 2 heads in there, one with 16 nozzles, one with 3 nozzles. The throughput on this thing is something like 5 parts, 6 parts every second is what this thing can pick up and place down. We've got an Omron stencil print inspection system, as well as an AOI system that we're doing all of our programming on. We've got an 8-zone reflow oven that we teach molding. We teach them what it is to be able to put a board through the temperature profile something. We've got a creative electron X-ray microscope that we train students on how to look for solder voids with. We've got BGA rework tools by Mancorp that we teach them. Here's how you align up a BGA. And every student who takes that class hates BGAs at the end of it. Like, why are we using these? They're such a pain to be able to put on and everything like that. And we tell them that this is what's in modern design. People want more functionality in their electronic devices, so you got to know what to do in case it doesn't go right. QFNs. And we've had in several. Yeah, right. Yeah, same thing with QFNs. We make them put down QFNs with them, and then they all hate them afterwards. And it's like, well, yeah. Now guess what? It's on a truckload of these boards with it. So in Merit, we have a lot more of the high volume based equipment for training the students and educating the students in their nighttime classes. Because usually when they're taking classes there, they're all working during daytime shifts or on the Train Ohio schedule on different places to there. And they swing by us, they take classes over at night. which allows us the luxury of being able to offer workforce training through merit during the daytime hours. So during the daytime, should a company be interested, if a company wants to hire our students or get put a job description near us, we'll do it. We've had a couple of companies from outside the Ohio area. I think Courtney, like 12 companies, something like that. So 15 as of late, the last year or so. And they've said, we want students out of this program. Here's our job descriptions. But, could you train our folks if they fly out there? We say, yeah, we'll train them up. We'll teach the exact same thing that we're currently teaching in our associate's degree and bachelor's degree. We'll teach them in short-term private seminars so where it's still hands-on. They still can see the equipment. And we actually just had a company do this just last week. We had a company come in. They've hired 3 people who have never done electronic manufacturing before. They've never seen a soldering iron. They have no idea really what a pick-and-place system is. They were surprised to see that solder paste was made of these small particles. I thought it was just some gray moosh is what it is. We put it in the microscope and say, look, there's the solid pieces, right? Let's actually reflow it so you can see what this looks like afterwards with it. And we're able to train them up in short-term private seminars so that they're able to get the hands-on training, same hands-on training that a student gets, but in a shorter time frame and at a higher cost with it on there, since it's a private class.
Was all that equipment donated, or was that part of your startup costs?
No, we bought it. So the college asked for funding originally from the state of Ohio to get some of the equipment for our associate's degree, and to which the state had a kind of a strict requirement. They said, you need employer support to be able to do this. And we said, sure, we'll get employer support. We'll make it to where the students got to be hired in as part of our program. And then the state gave us funding for our first laboratory. And then eventually we expanded into an additional solder laboratory. Once we became the first community college in all the state of Ohio to have our own bachelor's degree in microelectronic manufacturing, the college just put money towards buying this equipment and spent all the funding to be able to get this third laboratory of high volume production equipment built with it on there. But it's not being used. It's so awkward, Mike, because we get companies that are like, well, what kind of research are you doing? What kind of prototyping are you doing? What kind of products are you building from it? I'll tell them the same thing I'm telling them every time. The product is the people. The product is the people that we're pumping out, right? We got students who are coming out of the program who are trained up in how to do this. If you want to send us your workforce, we'll train them up there too. We'll train up new workforce coming in so that they have a clue what's going on with this here in terms of, and using our college education appropriately with this here. So we're not heavily involved in any kind of research or prototyping. In fact, we're not involved with prototyping anything at all. We get companies that say, hey, can I use your equipment to build something? We've got a fully automated line. We could, but we say, here's our company supporters who are already hiring our students. We'll train up your folks, but if you're looking for other companies, here's a whole bunch in our area that can do this types of work.
So all that hands-on learning means that you have to have good teachers. Tell us a bit about the instructors. Does the faculty,
Right.
In your case, it's drawing on your own industry experience, but how do you go about recruiting staff?
It's funny. Courtney and I were just talking about the mechanism that we've got or maybe lack thereof as of right now. We're young. We're only 8 years old, and we feel somewhat that we're not new, but just like unique in the United States. I'm not aware of a lot of other places that are doing what we do, and I'd love to know more if there are. I'd love to be able to get some feedback from folks on to other places that are doing something similar to what we're doing, because what we're doing is working. So if it does exist, can we talk to you? And if it doesn't exist and you're interested, can we share what we're doing with you so that we can spread this out? Like, this is working. This is working really well. So the faculty and staff that work with us typically are coming from 2 places. Number one, the first place that they're coming from is our industry supporters and places where they've already got working experience with there. Now, if they're going to be a part of our educational system, they got to also have some degrees. If they want to teach bachelor's degree classes, they got to have a master's degree. If they want to teach associate's degree classes, they got to have a bachelor's degree. So we got to find this nice mix of like someone who's got a degree as well as someone who's got experience. And I want more experience with it. I want someone who is interested in, like, who's seen what some of these things are. Occasionally we get some PhD who calls us up that's like, yeah, I want to talk to you. And I say, what kind of work experience do you have? And they go, well, I've got 30 publications and this and that. And it's like, well, what companies have you worked for? And the answer is zilch. So they don't come over. They typically don't make their ways over here. The second area we're ironically pulling folks from are kind of a homegrown mechanism that come out of this program. We've got several student workers and technicians who are actually graduates of this program that see this interest in, like, oh, I want to help other people find work and employment. They've had some work experience out there, but these folks are ultimately interested in being able to help additional students, help run our equipment and everything like that, help keep the laboratories clean, help train other people up, train themselves up with it in terms of what they do. One of these times a while back, the couple of students, student workers, they didn't have anything to do at the time, and I said, go downstairs, load every feeder up. And they sure did. They went down, tape and reel, got a bill of materials, and loaded up every single feeder. And then they said, it's all loaded up. Now what? I said, tear it down and do it again, right? Because they got to know how to be able to do it. They got to look good while they're doing it, show other students, hey, this is how you do it with it on there. So a lot of times it's just coming with practice to be able to do it. As the program goes, we are somewhat of a smaller program, including Courtney and I. We've got about, I got to think, 4 instructors within the program and 3 student workers and a couple of laboratory assistants, or a couple of laboratory techs is what we've got. It's not the mightiest of programs, but we're willing to grow. We're interested in, not that we're willing to grow, we are growing with it. We're growing very much so with the natural way that other companies are going to want to hire people in, and just kind of watching as that sort of grows to see how it is that we can provide them better workforce with it.
How many degree students can you take each year?
Oh, that's a good question. So prior to COVID, we were actually just ready to expand to either 36 or 48 students every single year. Now, what happened was COVID hit, and yeah, everything's bad with COVID with it on there. But for us, it took a pretty nasty toll because 2 things happened simultaneously. Number one, the college asked a lot of folks, hey, if there's anything you can teach online, try to teach that from home. And the problem was, I tried to get soldering iron sent to the students' homes, and we just couldn't do it. There was too much stuff happening with it on there. So we require a lot of hands-on training. So the students got to be on campus to be able to do that. That alone led to some difficulties in training and learning and everything like that. But on the other side of the fence, the other problem that hit was that companies that were manufacturing biomedical electronics, specifically the hospitals, all of a sudden had second and third and other shifts that just popped in out of nowhere. Courtney and I have never seen so many job requests being asked from companies. These students literally have a huge amount of job opportunities that are available to them should they be interested in taking a position. And so we've got kind of 2 things happening kind of simultaneously with that, one versus another. We've got, as of right now, we're taking, I think it's 24 or 36 students per year. For COVID restrictions wise, we've got to keep the class sizes limited. We've got to keep everything kind of limited. But once it starts to change a little bit more and we're allowed to increase to higher capacities, we expect to go back to a full set of classrooms the way that we were back in 2019, where we had all of our class seats maxed out for years prior to COVID, with in some cases an almost waiting list of students to be able to get into this program. Although the college didn't have like a waiting list necessarily, they just had them taking some other classes in other places with it on there. But a lot of students see that this program leads to careers, it's affordable, and in some of the cases, these students are really interested in what it is that they're doing. They're really interested in just working with their hands, working with local companies, working with materials and equipment that is of interest to them. And so we're expecting after maybe like a year or so that this goes back up to maybe 36 to 48 students every single year. But we do expect it to climb even further beyond that. It's just the job requests are just huge as of right now. And right now we don't have enough students to provide all of the job requests that are there. But are we going to work towards getting them those students and getting them those workers? You bet.
Johnny, at the top of the program, you mentioned that when the program began, you had 8, I think, corporate partners, and now it's something like 80. That's grown tenfold over the life of the program. What is the nature of that partnership? Are they advisors, sponsors? They're companies that are helping place your graduates. I mean, just all of the above.
Yeah, in many ways, all of the above. These companies that support our program, our industry partners, are first and foremost our advisors. We don't want to teach students or train people in things that won't lead them to careers. And in the early parts of our program, that was part of it. So we had a couple of companies that did fabrication processes and said, we want more chemistry, more chemical handling to be within the program. And so we kicked physics out as a science class and introduced chemistry into the program instead, and created a fabrication class where students are doing chemical processing on bare printed circuit boards. We originally had calculus in our program. And to quote Greg Vance of Rockwell Automation, he says in front of a whole bunch of people in the state, he says, I don't need someone to do a damn derivative. I need someone to work for my company, work with my team, work with my equipment, and make my company money. We make circuit boards, and that's what I want the program content to be in. And that's what we did. We kicked calculus out. The highest level math class in our program is a statistics class, which is appropriate for the discipline of what it is that we're training people to do. We're training people to be designers, manufacturers, technicians, operators, and manufacturing engineers. In some of the cases, doing integrals and differentiation, everything like that, it's just not going to give them skills that are going to be necessarily good for that particular career. Are those classes worthless? Well, maybe not entirely. Like, they're just better for other degrees with it on there, is what I'm saying with that. But ultimately, a lot of where these industry partners come in big play next is in hiring our students. It's partner or perish, Mike. We either get our students hired in to work with the companies, or we perish. We cease to exist, is what it is. And so we're very interested in the feedback from our industry partners. We're very interested to hear what is it that a student should be knowing in order to get hired in. What is it that we can give them in terms of that experience? Because if they don't get hired in, they don't get that paid working experience. They don't get their degree, and Courtney and I don't take home paychecks. Or really more, just our degree ceases to exist at that point, and then we got to start teaching math classes or something like that.
Well, and we also understand that not every employer can hire someone all the time. So we invited employers to the table to even just provide feedback in hopes that in 2 years from then they could hire someone and their feedback has been part of the process. And so employers along the way can review resumes, provide mock interviews, provide degree feedback. We want employers at the table, whether they can hire someone today or in 2 years.
To recap, you have an associate's degree program, an applied bachelor's program. Students can come from really any walk of life. Sometimes they are already employed and coming to LCCC. Sometimes they are coming to LCCC and then finding employment. Every single one of them that has gone through your program has been hired. And while you developed this program essentially from scratch in conjunction with a number of other, industry, manufacturing companies, some of which are, blue chip companies. You mentioned, Greg Vance at Rockwell. The program itself, hypothetically, could be, or the model at least, could be packaged and offered at other community colleges around the country. Is that a fair assessment?
Yeah, we think, even to add on to that, Mike, in addition to 100% of all students who have graduated being hired in, 85% of our current students are working as part-time workers, as interns, or in some of the cases, they're full-time workers while they take part-time classes with us. Again, it's all different, depends on the companies, it depends on the student schedule and everything like that. But yeah, that ability to have what it is that we're doing duplicated elsewhere is a big factor of what we want to talk about. In fact, we're currently working as part of a grant that the Air Force provided to the state of Ohio called ADMEET. And ADMEET, gosh, I can't remember what the acronym stands for. Some of the people on my team, they probably wouldn't be able to know what it stands for off the top of my head. But yeah, it's basically there to train students to work in trusted and assured microelectronic solutions, is what it is. And it's based on 6 colleges kind of working as an ecosystem together to create degrees and create training opportunities. And one of the ones that's working strongly with us is Wright State University. Vance Saunders and his program that he's got down there has a computer science and engineering program down there to where students are interested in learning how to solder up circuit boards as a skill that would be beneficial for them working at companies. So Vance is asking us, hey, can you share some of the content with us that you're doing? We say, yeah, here you go. And then we say, hey, what kind of equipment are you using? Here's the exact equipment that we got. Now Vance has the third problem of who's going to do it. And we say, send us your folks. That's what Merit was built for. Merit is built to train not just workforce, but other institutions in the areas of electronic manufacturing. Send us your workforce, or send us your faculty, your staff, your grad students, your adjuncts, your whomever you want to have with it on there. That way, they get hands-on training in short-term classes. They go back down to Wright State. Now Wright State has a laboratory with equipment that's going to train people to work, educational material that came from us that's based on what industry around us wants them to be trained in, and they've got a training mechanism for in case somebody else graduates, goes to work somewhere else, and oh, we got to send someone else over to LCCC's Merit to get training. That's a possibility for them to be able to do as well. All of that combined together makes for a well-rounded, hands-on training ecosystem that any university in the entire United States, starting with Wright State, could be able to do.
Well, this all sounds fantastic. And I mean, as I mentioned again at the beginning of the program, I joined the industry in 1991, and back then there weren't enough workers. And, in 99, 2000, 2001, when the industry was really at its peak in North America, there absolutely weren't enough workers. When the bottom fell out in the recession of 2008, 2009, there still weren't enough workers, even though the unemployment rate had jumped up to 8% or whatever. I mean, there's just never enough workers for this particular industry. So the fact that you're offering design, fabrication, assembly, all hands-on, it's something that assemblers and, well, all employers really have been begging for years. And nobody has ever kind of stepped forward and done the heavy lifting to develop the program. So I give you guys a lot of credit for not only seeing the need, but then actually, attempting to fill the gap. And it's been long overdue. So congratulations for that.
Thank you, Mike. Thank you so much.
Anything else? Is there anything else that we should mention to our listeners before we wrap up for the day?
I'll say that if you're interested in any more content about what this is, the website for what we've got is www.loraincccc.edu. And if you're interested in the education, put a /MEMS after that. If you're interested in workforce training, put a /merit after that. And we can get you more information on the curriculum, or there's some videos, there's some success stories. In particular, one of my most favorite success stories that we've actually got as of right now is we had an Army veteran come in who was a medical technician in the Army. He used his GI Bill to get some training. He became one of the first graduates of our bachelor's degree, and now works for a company in Valley View, Ohio, which manufactures flexible electronic circuits for Walt Disney. And it's just such a good experience to be able to help veterans like that. There's so many success stories that I could potentially, like Courtney, right? There's so many success stories that we could talk about within this program. And every one of them is a success story. every one of the students that graduates and gets hired in is a success story, as well as the companies that are hiring them in. Because those companies, they get one person maybe out of this program, right? They've got their first person that came in. That person has helped them grow. And all of a sudden they come back to us and they say, can we have more just like them? Can we have more just like the one that you gave us? We'll take it. Like in some of the cases, some of them will ask for 10, 20, 30 more of them, just like that in terms of where we are. But yeah, so if you want to know more information about the degree or for the workforce training, head on over to those websites there for some additional information, or to get a quote for any kind of training, check out our equipment, everything like that.
And folks, Lorain is spelled Lorain. Our guest today has been Johnny Vanderford and Courtney Tenhover from the Lorain County Community College MEMS program. Maybe next spring you can join us again with some of your newly minted graduates.
Yeah, we'd be happy to do that. Thanks for having us, Mike.
Thank you.
For PCB Chat, this is Mike Buetow. Have a nice day.